probability. Give me a sentence that like has probability in it. Somebody make one up.
Probability. Oh.
Give me a sentence that has probability. I want to see what you know.
What is the probability that you will die on the 5?
Not a question. I want a statement. So the probability is
the probability that land on a 5 on a die is 3/5.
Okay, 3/5. Probability can be expressed as a fraction. All right, that's one way that we can express probability. All right, how else could we express probability? Can you give it to me in a sentence?
Yeah, the probability that the coin will land on tails is 50%.
Okay, we could do a percentage. Perfect. All right, a fraction, a percentage, any other way that we can do as a ratio, okay, like?
The odds are 3 to 1.
Okay, the odds are 3 to 1. That's actually the reverse of probability, because then you would say the probability is 1 in 3. Right? The odds are 3 to 1. The probability is 1 to 3 because it's a fraction. All right. So again, so I would say that that's kind of the same as a fraction. All right. Anybody else? A decimal. Okay. Can you think of one?
The probability that I'll take the math final is 1 or 0.99.
Okay. 0.99. So a decimal. All right. In any of those, you can never go higher than the equivalent of what would be 1. All right, in a fraction, you would never go higher than a fraction of 1. In a decimal, you would never go higher than 1. In a percentage, you'd never go higher than what? 100%. All right, so the max is always 1. Now, whether that in a fraction, okay, the max for a fraction, what is going on here? I've lost. There we go. All right, the fraction would be n over n. It's never going to be more than 3 out of 3 or 5 out of 5 or 10 out of 10. Okay, 10 out of 10 people, if you notice some of my posters in my room will say like 5 out of 4 people have problems with fractions or probability, all right? It's an invalid thing. You're never going to be more than 1. In a percentage, you would be never more than 100%. In a decimal, you'd never be more than 1.0. Okay, so percentages or probability is always maxed out at that. All right, the next thing you need to know about probability are some of the words that are implied in a question. And that was what I was talking with Vincent about earlier, the word and the word or. Sometimes the word and is explicit. You'll find the word and in the sentence. Sometimes it's implied. And you're going to have to infer that the word and could be there. You might want to rephrase the question, would put and in yourself and see if it still makes sense. If the word and is in the problem, this is multiplication probability. All right, the word and always implies that there is multiplication going on, whether it's in permutations or combinations or probability of the word and. The word or implies that there is the addition of probability going on. But when you add 2 probabilities together, you might get more than 1. You might get higher than 1. So you also have to follow it with subtraction. So it's kind of weird. It's addition followed by subtraction. And I'll show you how that works in just a minute. And the reason we have to follow it with subtraction is because we can't be higher than 1. We have to protect ourselves from getting more than 100%. So I'll show you how that's going to work. All right, so look for those clue words, those key words, if you might be able to find them. All right, here's a couple examples. And then we have an extra credit opportunity in just a minute. But we got to do our examples first. All right. So let's talk about a deck of cards. What is the probability of not drawing a heart? All right, well, let's see if we, some of you just know it, but let's talk about the mathematics behind that. Okay, the probability of not drawing a heart or selecting or being dealt a heart. Okay, well, what you need to know about a deck of cards is how many total cards there are.
Actual heart.
Oh, I don't mean,
Yeah, I'm pretty stupid, I'm sorry.
Yeah,
about-
I'm like, well, you just drew one. That was-
how about I rephrase? Choosing
There we
a heart. All right, how many total cards are there in a deck? That would be something that you would need to know about probability. Does anybody know? 52. If you've ever played 52 card pickup, you know that there are 52 cards in the deck. Okay, now, how many hearts are there within that 52? There are 13. Okay, there are 13 cards. There's a 13 that go from 2 up to 10, and then you have the Jack, King, Queen, and then you also have an ace. And so that's a total of 13 altogether. So the probability of not choosing a heart, all right, well, how many not hearts are there? Which is 39. All right, so hearts are 13, not hearts are 39. And so then the probability is expressed as a fraction, 39 out of 52, or as Tessa already reduced, 3 out of 4. And so then, like Luke was saying, if you say the probability is 3 out of 4 that you won't get a heart. And if we were talking about odds, we would reverse that. The odds of not getting a heart are 4 to 3. Okay, it's backwards when you say it that way. So that's an example of not exceeding 1 in probability. Here's another one. Okay. Choose a red card. Then roll a prime number. So now we're doing cards and dice. Okay, choose a red card, then roll a prime number. All right, so let's talk about cards here. All right, so first we talk about the total cards. We know that there are already 52. How about how many of those cards are red? Half, which is 26. So the probability is 26 out of 52, which reduces to half. All right, now let's talk about the dice. All right, so the dice sides. How many of them are there? Assuming we're talking about a regular dice here. 6. All right, there are 6 sides on a dice, 1 through 6. All right, but how many of those sides are prime sides? So now we got to talk about what a prime number is. Does anybody know what the first prime number is? 2 is the first prime number, right? 1 is not considered a prime number. The definition of prime numbers start at 2, and then from there on, it's any other number that's only divisible by 1 and itself. So how many of the sides of a dice are considered prime? 2 and 3 and 5. Okay, why not 4? It's not a prime number. What about 6? Not a prime number. All right, so how many of the sides are prime? 3. So that would be the probability, 3 out of 6, or also 1 out of 2. All right, so what do I do with these two probabilities? Do I add them or do I multiply them? Okay, well, let's go back to the question. The word and or is not in the problem, but put the word and or in there and see what would make sense. Is it choose a red card or then roll a prime number, or is it choose a red card and then roll a prime number? This is and. And because it's and, this is multiplication. And so even though the word and wasn't there, we infer that the word and is there, which means we take our two independent probabilities and we multiply them together. And so the chances, the probability of both of these events happening in a row is 1 out of 4, or 25%. All right, our final example, and we'll get to the extra credit. Okay, so our final example is this. Suppose you want to draw a diamond or a 7 card. All right, so the word or is explicitly in this problem. All right, well, let's talk about drawing a diamond. So once again, we just think about the total cards. We have 52. The diamond cards, how many of those are there? 13. Who's saying 4? Oh, we haven't gotten there yet. All right, we're just doing diamonds. All right, so a diamond, just the diamond cards is 13 out of 52, which reduces to 1 out of 4. All right, then we do again, the total cards is 52, and the 7 cards, all right, Luke, how many 7s? All right, so that's 4, and so that's 4 out of 52, which reduces to 1 out of 13. Now the word or is clearly in this question. And so or implies that I take these two independent probabilities and I add them. So 1/4 plus 1/13. But I have to be followed by subtraction. It's not just as easy as just adding them. Because there is one card that embodies both of these characteristics, right? Okay, what card would fall into both categories? The 7 of diamonds. And so if I don't subtract, I've counted it twice, and my odds are going to be, my percentage is going to be too high. And so I have to take away the one single card, 1 out of 52, that would be in both groups. And if you don't subtract, then on the multiple choice part of the exam or whatever, you're going to pick the wrong number because your answer is going to be too high. All right, so grab out your calculators, use the math fraction option, and go ahead and do 1/4 plus 1/13 minus 152, and tell me what you get.
Okay, you can just leave it as like 13 out of 52.
Sure, yeah, you could totally just have left it as 13 out of 52 plus 4 out of 52 minus 1 out of 52. That may have even been faster. 13 plus 4 minus 1? 16 out of 52 reduced into 4 out of 13. So you have a 4 out of 13 chance of selecting either a diamond card or a 7 card. All right.